Could a beam of light ever literally turn into a particle like an electron? In the energy filament theory, it can, but only when a moving light filament manages to lock its own ends together and becomes a closed ring instead of a passing ripple. Earlier we pictured lights not as little bullets, but as very thin, very short, twisted strands of motion in the energy sea, being handed forward from layer to layer. And we pictured electrons as tight closed loops in that same sea, with circulation running around the ring and a textured latch wrapped around the outside to keep the loop stable. In this picture, the relationship between light and particles is almost embarrassingly simple to say. A light strand is a ring that has not clicked shut yet, and a particle is the same kind of strand whose ends have finally latched together. When that happens, the energy sea stops treating the pattern as something to pass forward along a corridor, and starts treating it as something to circulate around a closed track. Think of a piece of rope with a wave traveling down it. As long as the rope is open, the bump runs along, reaches the far end and is either absorbed or reflected. Tie the rope into a loop and give it a shake. Now the same bump can run around and around the circle, never needing a new push from outside. The rope has turned from a road into a racetrack. A light filament turning into an electron is the energy sea version of that trick. The filament is a twisted, finite segment, with a head, a body and a tail. In normal conditions it rushes forward and eventually its pattern is absorbed, scattered or spread out. In extremely intense environments though, the path can fold back on itself hard enough that the heads and tails of the same strands are forced into the same tiny regions and pushed into alignment. The local swirling patterns that act as latches now have a chance to catch both ends and snap them together. From that moment, the relay changes character. The energy sea no longer propagates the strands along a long corridor. It hands the motion around the closed loop instead, supporting stable circulation along the ring. The moving filament has turned into a standing, self-sustaining loop, one possible way an electron can be born. How often does this actually happen in the real universe? The honest answer is almost never in gentle environments. Earlier we used a cartoonish but useful number. Imagine that out of 10,000 trillion attempts by light strands to lock, only one succeeds. That is like a 1 in 10 to the power of 60 to chances for a filament to become a closed particle loop. Now put that against something enormous, like sunlight. The sun throws out a ridiculous number of light strands every second. But even with that fire hose, if each strand had only that 1 in 10 to the 60 to chance of closing, you would have to wait on the order of 3 billion years before, on average, a single filament from ordinary sunlight managed to lock itself into a particle ring. From the point of view of daily life, that is the same as saying it does not happen. Everyday beams, room lights, phone screens, even bright starlights are simply not fierce enough, nor twisted tightly enough, to give light filaments realistic opportunities to meet their own tails and snap shut. Only in the most extreme arenas do the odds start to change. Near black holes where the tension in the energy sea is insane, in violent astrophysical jets, or in human-made strong field experiments where electric and magnetic fields are driven to absurd strengths. There the paths of light can be bent and folded, the strands crammed into tiny volumes, and the latching mechanism can occasionally fire for real. In this view, light turning into matter is not a party trick that happens everywhere all the time. It is a rare locking move that the universe only pulls off under stress, when conditions are so extreme that a moving filament is forced to bite its own tail and become a loop. Almost all the light you'll ever see is doomed to remain what it started as, a twisted strand just passing through, never sealed into a particle. Tap follow, share it on New Physics, Clear Universe.